So thank you everybody for joining today's coffee break, which is all on getting alerts into SCOM from any system, brought to you by SquareUp and Cookdown. So just to say before we dig into the actual content, at any point if you have questions, feel free to use the chat box, of course, of GoToWebinar, but a more effective place is to use the dedicated Slack channel set up for this webinar, which is at this below link. The details will also have been in the joining details email, but it's bit.ly/206LJ4N, nice and catchy. So if you have any questions, please put them there. All right, so just to quickly introduce myself. So I'm Bruce Cullen, I'm the Director of Products here at Cookdown, and with me I have a very special guest. I'm joined by David Smith. David, you're a Senior Systems Engineer at Wellspan. Welcome.
Good morning.
Hello, it's great to have you with us today. We talked a bit about this this coffee break and this topic after sort of SCOMathon back in June, and it's very much resonated with our audience. People are very interested in getting everything into SCOM and using it as their single source of truth and single pane of glass. So it's a really cool topic to talk about. But let's start with some basics here. Why are people even interested in getting alerts into a central system? Well, the answer is actually relatively simple. In almost all companies, SCOM is not alone, as it's not the only monitoring tool that exists. And each of these tools, this is just a selection of the sorts of tools you may get. Obviously, there are many more. Each of these tools generates notifications and alerts and messages in varying fun formats, entirely inconsistent between the multiple systems that you have. And ultimately, each of these tools has its own kind of console, its own method for delivering these messages. And when you come to sort of look at these, this data, it often ends up with you having to look at multiple systems, which is a pain. So people are looking for basically a single source of truth across all of their monitoring tools. So how common is it really that companies have got multiple monitoring tools? Well, I've got some hard data on this from the Big SCOM survey, which we did in January of this year. One of the questions that we asked was, what other tools do you use for monitoring, obviously aside from SCOM? And this is what we got back. So the first thing you'll notice is there's a large number of people that have answered. We had 118 respondents, and of those people, only 6 people said they use SCOM only. The other thing that's really interesting about this data is this, the graphic up on the screen here has 296 responses, which means that on average, if you take out the 6 people who are only using SCOM, there's an average of 2.6 monitoring tools per company on top of SCOM. So that's not nothing. The other thing to note about this sort of data is there's a large number of tools here, and just to pull out this other category quickly, so that's like 5th down from the top, and it has quite a large number of responses in this category. And the list of tools, this is just for me looking at the data and pulling out a few to stick on a slide. There are hundreds of tools out there that people use to monitor things with. And again, that makes total sense. It's typical that companies will use the best tool for each thing they're trying to monitor. And for some things that will be SCOM, and for others it won't be. And that's fine. So clearly there are a large number of monitoring tools out there. So then the next question is, great, Bruce, you've convinced me that there is a problem here. Why pick SCOM? Why aggregate all of your alerts into this system? Well, the answer is actually relatively straightforward. SCOM generally has quite broad sets of coverage, especially in Microsoft shops, because it monitors a large number of Microsoft technologies out of the box already, which means that versus integrating SCOM alerts into other systems, more things are already in SCOM sort of natively. And that's a big one. But there's also a few specific things, specific features, if you like, of SCOM that make it very valuable as the sort of central source of alerts. And the 2 things that really stick out for me are its health model, the fact that you can have you can have monitors essentially, things that have states and can go red, amber, and green, and the fact that That health and those alerts can be associated with classes, and an object model that's hierarchical, isn't flat, isn't sort of simple and straightforward. It's a relatively complicated class structure, which gives you loads of flexibility to create exactly what you want inside of SCOM. And the final point is that DAs within SCOM allow you to bring the ability to monitor applications to everyone. There are some tools in that previous list, like Dynatrace, for example, that are great for APM, so application performance monitoring, but they're so expensive. You wouldn't use a system like that for every single application, but the value of monitoring applications on top of just infrastructure is clear, and SCOM allows that with DAs out of the box. And if you have a system like Squared Up, then with EAs as well. So I've sold you now on the use case for making SCOM the single source of truth, essentially, and pulling everything into SCOM, which is where I'll bring in your solution, David. It's an awesome solution. It allows alerts to be brought in from any system into SCOM, and it can be expanded to use with any tool you like, essentially. It runs a custom Windows executable, and a really key point is it's open source. Another thing to mention about your solution, David, is you built it initially for vROps, which, just to pull back in this survey data, is third down from the top. So it's clearly a very widely used solution. Obviously, it has applications outside of vROps, but that's what we're going to be demoing with today. So hopefully that sets the stage for you nicely, David, to talk a bit about the architecture and how your solution works. So I'll click on.
Sure, yeah. So basically you have your SCOM management server and you have agents. So if you have Windows or Unix agents, that's great. They report in as objects into SCOM and you can write monitors against those. But what we didn't have was a way to get alerts into SCOM for objects that were discovered as nodes. You might have appliances out there. If you're working with vROps, you know that it's an appliance-based solution now in version 8. So we wanted to try and tie the vROps alerts into SCOM without buying a product that would allow us to do that. So after doing some looking around, I found the SDK for the programming in C# to allow us to link into that. And basically, the flow of the agents comes in as objects. You advance the slides for me? Yeah, there we go.
There we go.
So SCOMalerts then is an executable that runs on a Windows platform, and it will generate alerts based on the object type. Colin mentioned that, object types are class-based. So we based it on the class of Windows, Unix, and network node internally. And then that will generate an event within a standard management pack that collects data access service data. And that event then comes into the SCOM environment. From there, then we have rules that will look for and target the entity SDK event data provider to generate alerts within SCOM. So it all starts out as an executable generating an event into SCOM, which then a rule interprets that and puts it as an alert. And it also associates the object with that. So it's not just coming in from, say, your management server. It actually displays in the alert console as the object that was discovered.
Makes sense. It's a very sort of sensible approach, particularly the use of the SCOM SDK rather than anything directly involving the database. So it looks like it's got great application for other companies.
So how it works. Basically, there's a utility I wrote, cryptpassword.exe, that will create and store the password in a file named empw, and then rename that file to something else so it can't be hacked or people don't know exactly what the name is. There's a SCOMalerts.exe.config file. That's the parameters for the actual executable, where you configure the server, the password file, logging, and debug. And we'll go into that on how that's configured. There is a log file and debug option, so you can make the debugging output from the SCOMAlerts executable more robust or less robust depending on your needs. And basically the SCOMAlerts comes with a help, and there are 5 different parameters that you have to specify. Basically the server agent -svr has to be the name of the object that was discovered, either the node, the Windows, or the Unix object. And then there's a message, which is just a free format. You can put anything in there that you want. Set a level, 1, 2, 4 corresponds to critical warning or informational built into the SCOM product. The event number, that is something then that's going to be leveraged within the rule to be able to generate the alert, and that can be anything you want. And then the type is either node, Windows, or Unix. I need to point out that node is a network node, not a cluster node or any other type of node. I just use the word node because that's how it was stored internally within the class. So that's where I picked that from. And then we'll also show you the custom.event.alert XML, which is a simple XML to get you started with this, to detect the event and generate the alert based on the event ID 8100. So the SCOMAlerts.exe.config looks something like this. It's just key value pairs. So if you're familiar with C#, this is pretty straightforward. Basically, you're specifying the SCOM user, an account that has access to be able to write into SCOM events. The password file is where we use the crypt executable to create an encrypted password file. The SCOM server, so the management server where you want to connect to generate the events and alerts. The domain name, as well as the log file location and whether or not you want debug to be set to true or false. So the settings are pretty straightforward and fairly simple to get created and get going.
They are.
This is just a sample of the output log that's generated. You'll notice after the date and time, there's a unique parameter. I do that with all my logging just because a lot of times I'm creating one log file, and that's just a unique ID randomly created every time a script or program runs to put that key in there. So if you're using something like Notepad++, you can just highlight that and it'll show you all the lines in your log file. A lot of times we have logs where multiple things are writing and things get broken up, so it's hard to track that one particular instance of your script or program running. And it just displays out the key values that you're beginning. And also if you get any errors, it will tell you there was an error. There's not a lot of robust error checking. This pretty much, you either can connect or you can't. So I didn't build a lot of that into it for whatever reason. That's just the way it is.
Well, ultimately, you know, it is open source, so if someone out there wants to add more to it, they're very welcome, and that makes sense to me. So let's see it. I guess is a good place to now make you presenter and see it in action and see how you get going with it. So I'll make you presenter.
Okay.
I can see your screen.
See a screen?
Yep.
See a mouse? Okay. So basically, we'll just start off with some simple tests of how it works to show you that it does work. And then we'll go into some of the details of how it's configured and how it works and how the alerts are actually created. So basically, I just created some little test scripts here. One thing to note, the default type, if you don't specify the type, will be a node. And if you specify the wrong information, it will fail. So if it's a node, like in this particular case, this is just our test environment, and we enter that, it will run. It also, I have it right now set up to output to the screen, and that will run. And you can also use it with the dash node. But if I choose to pick something that doesn't exist as an object in there, you will see it will start, it tries to find the object, and then you can see you get an error retrieving the node info. So it will tell you if that object is not in there. So it's important that when you specify the name here, that is correct. If that object does not exist in SCOM, it will not run. You will see this error right here. So that's something important to note in troubleshooting when you're trying to get this to work. That object has to be discovered.
Mm-hmm.
So you can see we got our first one in here. It's just an informational. You can see there's our test message without the type specified. So the alert came in, and I built just a little folder just to show the events and alerts coming in. So there's our actual event. If you look at the all events area, you can actually see the SDK connecting and disconnecting from the environment. But you know, that helps in troubleshooting when you're trying to figure out what's happening with your events. But for today, we'll just look at this in the alert. So there's one that's informational. That's from a node. We'll do another here just to get these all queued up. Here's one for a Unix. It's actually a Linux device. Oops. And we'll do a Windows device as well.
While that's loading, one quick question. Is there a reason why you chose to pull everything in as events rather than make everything that comes in become an alert?
Yeah, good question. When we first started working with SCOM 9 years ago, one of the things we found was you couldn't directly write alerts
Yeah.
to SCOM, but the event engine would allow you to generate alerts based off the events. So that's why we chose to do it that way, because there is no direct way that I'm aware of to write alerts directly to SCOM.
I believe that's still the case. So as far as how you've used what you've built, are there cases where you don't raise alerts off of events, or do you always typically pull them through as alerts as well?
We're typically using this to generate alerts, and our alert engine within SCOM is tied to an incident generation system. So that's what we're doing this for. We're not just getting it to store events. We actually want an alert to generate an incident to a team to address whatever issue has arisen.
Makes sense. That's what SCOM does best. Thank you.
Yes, it does. And it does really well. And that's why we like this as our single pane of glass, because it's tied into and we're using Remedy Force to generate tickets to people. So that's already built. So we don't have to build another environment using scripting or programming to get alerts into that environment. We can just leverage SCOM. It's in there. Our operations staff can view it and look at it, and they can keep track of things to make sure that these issues that are arising are getting taken care of. So we can see now we have our custom node object with its details in here for the event. And again, these are all events. If you modify the code, you can change the source to be whatever you want. I also show you later on how to change the event number. I just picked 8100. Don't ask me why. I just picked that. So there's our Linux device. And you can see, oops, I must have my message wrong there. In that, and test event for Windows Node. And then what happens is this collect data access service event data is an internal System Center Operations Manager data access service monitoring. It's part of their inherent management packs that come with the product. So that's what I leverage to get the event in there. And then from there, we created rules. Hopefully these will show up here. There we go. It just took a while to refresh. From here, then we have our custom rules. And I just set those up, one to be informational, one to be warning, one to be critical, just to show you that you can change all that. And you can see we have a rule on a Unix event for 8100. We have a rule on a computer or Windows event for 8100, and we have a rule for the node. So there are 3 separate rules for the 3 separate node types. And basically that's something that we have. I have 3 management pack fragments, 1 for node, 1 for Windows, 1 for Unix. I also have an XML that includes it all just as a sample to work with this 8100 code. And you can see I just put it in a management pack called custom event alert. And its target is the node, and its configuration is pretty straightforward. If you look at the write action, that's just generating alert. There you can change the priority and severity of the information, change the description, just as you would with any other rule that you created for monitoring in your environment. And the target SDK, that's really just the internal code. What it matches is the source, which is also called the publisher name of the event, which was custom alert, and the event number 8100. So that is how it recognizes and filters all the events that are coming into your SCOM environment. And each one has their own rule. So that was the node. This is Windows. Again, same sort of configuration. It's just tied to a different object. You can see the Windows is a little bit different with its configuration, but again, it's still matching on the source of custom alert and the event number of 8100. Same with the Linux or Unix. It just so happens that that's a Linux system. Again, same sort of XML that's written to handle that. And the same with the filter. Again, you can set that filter to anything you want. And this is how you would change it to be a different custom event. So if we change that to some other number, we went back out here and ran this and changed the event number here to 8100 or 8101, whatever you want, it would work, and filter it and it would work. So that's how you then would modify it, add additional rules for additional custom alerts and events coming in. So that's how, real quickly and high level, of how it works. So we've generated the event, and then that's turned into an alert, and then you can do anything you want with it within the SCOM environment.
Sounds good. Lots of cool uses for it. Then presumably once it's in as an event, you can do whatever you want to alerts based off of those events. You can use everything that SCOM has in it with them.
Yes.
Yeah,
and that's why we designed it that way, so we could integrate this from other environments to get events and alerts into our SCOM environment.
Makes sense. Very cool.
So that's it for the demo. We can go through a little bit of how this works. So here's just the log file of what it looks like. You can see pretty much what we looked at. And if I want to look at just one, you can see there's all, now because these weren't run simultaneously, they aren't mixed up, they're together, but you can see it's just like the format. Here is the node info, index is out of range. It just means that basically it couldn't find the node in there, but all the others, as you can see, just fine. It found the object, gives you the object ID, full information. So it gives you a little more additional detail about the object. If you're having issues with that, it can be a good place to troubleshoot.
That's super useful. Nothing worse than chasing down a random issue with just a single line of event log. So that's awesome.
Yeah, and I tried to keep the logging minimal, but enough that you could troubleshoot where your issue lies.
Sounds good.
So as far as configuring here, I'll just show you a sample. I think I have it here. There it is. And again, this is just something simple. So you put in your SCOM user, your password file, your SCOM server, your domain, the log file, and debugging. And this is pretty much what it looks like. It's pretty straightforward. And that's, you know, in your environment, everybody's going to have something a little bit different. You know, those were just for this demo made up to show you that in there. So that's how that's set up. And you can see the password file is here. And there's the crypt password. I'll just show you that briefly. That's the other executable. And it's pretty simple to use. We want the exe. So if you just encrypt password and just start typing what you want to encrypt, oops, sorry, it's E or D. You can actually do decryption. I debated whether or not to include that in there, but I thought, you know, this is open source, so I wanted to keep it original to what I designed. So if we encode that, then we can see that there's a file out there, the ENPW, which it creates by default and encrypts it. Again, this is just basic encryption. The crypt code is not out there because I wanted to protect the hard-coded key that was in that. I don't want that out floating around the internet. So that's how we encrypt it. If that's not adequate for your environment, you'll need to modify the C# code, which is available, and, you know, put your own encryption or whatever your company requires for security. But I find this is just as secure as using PowerShell and the import export of the CLI XML files for encrypting passwords. So that's just my minimal security for keeping this tightened up so the bad guys can't get in.
Sounds like a good shout to me.
So that is it for the demo portion. Let's go through some of the custom fragments. We'll just go through those real quickly. I'm not a fragment guru, but if you're familiar with fragments, you can bring those into the Visual Studio authoring extension. Or if you're lucky like I am and have Silex MP Studio, it makes creating these quick and easy. But basically, there's just a class ID, the event ID, and the rule ID. And it goes through and builds out the rule. And this is just basically a simple find and replace. So if you want to just do it here, you can do a find, replace, you know, and whatever you wanted to put in here, test, alert, rule, and then it will append to that for the ID, the event number as well. So it makes it unique each time. So don't reuse event IDs. It'll overwrite and give you issues when you try and put your XML back into SCOM as a management pack. So you just go through and you find and replace all those items within here. If you want to change any of the message information, you would go down into the language pack section to change that. And so I tried to keep most of the information straightforward. If you did want to change, you know, the event information or description, you could do that. I just didn't include that as part of the fragment. I wanted to make it as simple as possible. And there's one for Windows, there's one for node, again, network node, not cluster nodes. And again, same sort of scenario, it creates a rule, looks for the publisher. This is where if you had a different publisher that you wanted to use, you could do that. Again, you would have to modify the code to handle a different source and event number. Setting your severity and priority is in there and handled as well. Again, modify the display strings to handle that. And of course, Unix, same sort of thing. You just use a different Unix source as your object. Again, event and rule ID for Unix. And these are just sort of samples of what's in here already. that you'll see in a moment in the actual XML. And again, same thing. So they're pretty much duplicates of one another, with the exception of the manage entity type, whether it's Unix, Node, or Windows Computer. So then the full-blown XML that comes with the product, basically there's the references in there, which are standard. If you're familiar with building management packs, these are just the standard internal Microsoft SCOM management packs that are added to, or reference management packs that are added in. The 3 rules, so there's one for Unix, Node, and Computer. If you expand that, it's going to look exactly like the fragment I just showed you earlier, with the condition detection and the right action to generate the alert. And again, the same thing down here, the language pack just contains all 3 of those items to, for your message alert, for whether it's Node, Unix, or Computer. And that one will work as is. So if you take the crypt password, the SCOM alerts executable, and this custom events XML, you import that into your existing SCOM environment, you can start using this today if you like, and it will all work as is. Of course, that being said, somebody will test it and find a way to make it not work. That always happens, right?
The whole "it works on my system" thing. I can verify we Cookdown tested it to make sure it works as well. So it does work in another environment, which is great.
Yeah. So I think that's about it for now.
Perfect.
As far as the demo goes.
Well, in which case, I'll take screen back. If there are any questions, feel free to put them in the chat or in Slack at any point. And I'll get to them when I get to them. And let me just reshare my screen. There are a couple of other bits to go through. There are a few things to note here.
Yeah, okay. So the password encryption is not FIPS 140 compliant. I think that's used a lot in government facilities. I wasn't aware of it. We don't use it. So just be aware of that. The password encryption key is hard coded into the crypt password. That's why I didn't make that available. So you'd have to write your own encryption if you wanted to change that to meet your company's standard. Again, just note in the SCOM alerts that the type of node is actually a network node, not a cluster node.
Mm-hmm. Makes sense. There is one other thing just to quickly show you, which is the actual source, and you've written a really nice blog up on it as well, also hosted on GitHub. We'll give out these links in a moment, but all the information that you've just gone through plus more is all on your blog here, and the source itself is available in GitHub. One of the joys of open source software is you can modify this, branch it, and modify it to your heart's content. The links you need are for the source code. It's on github.com/dpsmith005/SCOMalerts. And the blog is also up on GitHub, dpsmith005.github.io/2021/06/SCOM-events and alerts with hyphens in them. We'll make sure those links are available after the webinar. Really, really powerful solution. And best of all, it's free. But before we end, I want to just offer up a code-free alternative. If you'd rather go down a route that's sort of completely code-free, but that involves sort of paying for something rather than free and open source, and that's a product from us here at Cookdown. We are at SCOMathon back in June released the Connection Center suite of products, and one of the capabilities of Connection Center is the ability to get SCOM alerts into SCOM from anywhere using webhook. And it involves no code at all. It's all wizard driven. You import a management pack into SCOM, and this is a simple sort of 3-step wizard. You provide details around the webhook endpoint. Essentially, you give it a name, and it will be given a URL, which will listen for incoming webhooks, so those alerts. Then you provide a payload. So this is an example of the sorts of event or alert you're going to be sending into SCOM. Then using that example payload, you can shape the alerts here using a liquid transform language, essentially, to shape the alerts and see the example real time. So you can see here the variables have been replaced. I'm not going to go on about it too much on this call. Obviously, this is a SCOMathon coffee break, so all I really need to say is all the information on this is at cookdown.com/connection-center. So finally, a quick word from our sponsors, one of which is obviously Cookdown, who I am from. I've already touched on Connection Center, but Connection Center will allow you with no code to integrate anything into and out of SCOM, from ITSM tools like ServiceNow and Sharewell through to messaging platforms such as Teams and Slack, and ultimately anything you like with webhooks. And we're building on this list all the time. Everything you need to know on our stuff is on cookdown.com, where you can get a free trial and see a detailed demo of anything you like. Our other sponsor is Squared Up. Squared Up, as you will probably know, do awesome dashboards for SCOM and beyond. They are the not-so-secret source for SCOM success. There are a list of quotes here from various customers that have been happy with Squared Up, but essentially there are tiles in Squared Up that let you visualize and make use of all of that cool data that SCOM has in it, including the alerts you may get in using David's solution. So thank you to Squared Up and Cookdown for sponsoring SCOMathon. All right, now we can take questions. Let me just get up Slack in the background and just check there are none there. And I see nothing in the Teams, not Teams, sorry, go to webinar chat or questions. So if there are any questions, feel free to ask them now.
Hey, Bruce, did you want to go through how we've actually integrated this in with our vRealize operations environment?
Ooh, we have time to do that. Let's do that. Yes, let's do that. If I'm going to make you presenter then, and if there are any questions, we'll take them as we go. So I'll pass back to you.
Okay, thank you. So basically what we did is we wrote a script, and this script is actually run from within SCOM. So we just set up a PowerShell script to run timed. We run it every 2 minutes to try and get the alerts in a more real-time fashion. So with that, we have set up debugging and parameters environments. We use TLS 1.2, so we had to put that into our environment as well. Just some other different things. We have to ignore certificates in our environment for vCenter or vROps, just because we don't have the certificates quite tweaked yet. So I put that in there just so we could get by that prompt that would be created. And then if you're familiar with the REST API, that's what we used to connect from SCOM into our vROps environment. And if you're familiar with that, you know that you have to authenticate first, so you have to get a token. And this is all documented out on their site, so I'm not going to go through a lot of the details on this, but if there certainly are questions, we can go into more detail. So basically, we get the authorization token, and once we grab all that information, do some changes with timestamps. There was some, I won't call them issues, but just some challenges I had to overcome with timestamps and getting time set correctly with the universal time coordinate versus local time and things like that. So I had to do some massaging there to get the times correct so they would work right within our environment. We weren't getting alerts 5 hours behind time or with a wrong timestamp. So once we do that, we try and gather the alerts from vROps. And that's just a simple URL that's called to get the alerts. It's pretty standard. It's documented with the REST API. And it's just a call in to get the alerts. And we get the alerts in and gather them up, check for different types of alerts. So we only wanted certain types of alerts. So that way we didn't have to modify SCOM every time we change the vROps environment. So we basically just have this script and one monitor that will generate all alerts coming from vROps. Then the people that run our vRealize environment, they're in control from the vROps console, and they can control which alerts that we want to generate messages on. So we just set up some basic testing there. If that alert is configured to meet that criteria within this script, that's how we know to generate an event and alert in SCOM. So basically it comes through, that's just some massaging and some classes created to massage all the alerts. So I plunk them into an easy class array to get at the data. And what we did is we leveraged this notes field within each alert ID. And what we do is when we generate a SCOM alert, we just put the content for a note to say SCOM event created, because we didn't want duplicates created when we read it. So if for whatever reason the script would fail to run and it would go back in history and reread alerts, we didn't want to generate an alert for something that already generated an alert. So what we did is we just leveraged the note fields, do a write back into the vROps alerts with this content in there, and then this script will look through and parse the notes as well. So if the alert notes here doesn't contain SCOM event created, we know it's a new alert. Otherwise, we log it and just say, you know, this was a previously created alert. So what we do then, and I just export the data to a CSV file just so I can keep track of it. Early on, when we're starting with this, we had just some issues with getting things working, excluding different things until we got all that tracked and worked out. So I just left that code in there. That way I can look at all the alerts in a single file that were generated from a vROps environment into our SCOM. It helps me also troubleshoot if we miss an alert or that something of that nature. So again, it's part of the troubleshooting in addition to the log file. I can get all the specifics in there that were captured in this class, and that's why I created that class, just so it was nice, neat, and orderly to get into the CSV file. And basically, the section of how we get it in there is right here. It's real simple and straightforward. We're just using the SCOMAlerts executable. And if the alert in vROps level is critical, we're going to generate a 1, else we're going to generate a 4, otherwise we're going to generate a 5. And that those 1, 4, and 5s don't match to the 1, 2, and 4 that you saw earlier. We're leveraging that within our own custom code in our environment to give more granularity. And they also relate to how we generate incidents within the Wellspan organization. So that's nothing to do with SCOM. It's more for us internally to do that. But you could, certainly leverage any sort of way to change that if you modify the code yourselves. But basically, it just creates that. It just executes that SCOM alerts because this is run from the SCOM management server. That command and that folder exists on the SCOM server. So it's running this SCOM alerts right from the SCOM server itself to put the information in there. And then we just specify the name of the vROps server in there. And that's been discovered. That appliance was discovered with network node discovery within SCOM. And then that way, all the alerts that are coming from our vROps environment get associated with that vROps server internally. And I generated different event numbers so I could set different levels of priorities, different severities, as well as change the alert description for that information, all built with 3 different rules to handle this. And that's how that works within our vROps environment. After it's done, it just tidies itself up, closes everything down, and finishes with a logging event that it was finished. So that's sort of how we engineered monitoring vROps alerts and getting them into SCOM by leveraging SCOM itself to run a PowerShell script every 2 minutes that handles reading the alerts via the REST API, and then puts an event into SCOM where a rule finds it and then generates an alert in SCOM with that. So that, in a real high level, quick overview. I know it was kind of fast and quick, but that's just a real world example of how we leverage the SCOM alerts to get outside information or information from outside of SCOM into our environments. And vROps is just one example. We have other similar type node devices, appliances that we monitor the same way, that we can get data out of from various methods. You know, whether the appliance is writing to a log file and you use FTP or WinSCP or some sort of other mechanism to get at that file. Again, the sky is really the limit. If you can get at the data on that node programmatically, you can then leverage SCOM alerts, running something scripted within SCOM, and generate alerts within SCOM from that environment.
Perfect. Thank you for sharing that extra detail there, and sorry for not covering this earlier. Is this PowerShell script available with the rest of the solution?
I did not post this. I would need to scrub it to pull out all things Wellspan.
Yeah.
So if there's interest and someone wants it, give me some time, a couple days to get this scrubbed, and I will try and get it up on the GitHub site, and it'll just be called vROps.Alerts.ps1.
Perfect. All right. Is there anything else to show before I take back screen?
Trying to think, that at a real high level, quick overview of pretty much the product and how we engineered that within our environment to get alerts in. So no, I have nothing else at this time to add, unless there are any questions.
Perfect. Well, that's a perfect time to go back to Q&A. There is a question that's come in, which is relatively straightforward. The question is, can we get alerts from HCI solutions like VMware and Sang4? I think you've covered that one, but I'll let you answer it nonetheless.
Yeah. So if you have a mechanism to get into that, whether it's, you know, like I said, FTP or WinSCP or some way to retrieve data, or maybe that product can write out to files on other systems or send emails. Even if you use emails, you know, then you just have to have some sort of email catcher or scrubber that would read the email. And then again, obviously it has to run on a Windows environment, or the SCOM alerts executable was only set up for Windows environments. It's not built for any other environment. So you have to find a way to reach out into that environment and then pull that data back into SCOM to be able to run the SCOM alerts executable.
Makes sense. So the short answer to that question is yes, basically, which is part of the power of the solution. As you say, as long as you can get the data, then yes, you can. That's the only question I have. So I'll just give it another minute to see if there are any questions from anyone before we wrap up here. So just pause now and see if there's any final questions. All right. I'm guessing silence equals no. If any questions do come up after the webinar itself, Slack remains open forever. Oh, there is another question. What's this? Show us the GitHub source once more. Let's just put it back up. It is this tab here. We'll send the links out as well, but this is the GitHub source. All right. Unless there are any other questions, thank you very much, David, for taking the time to join me today and to show us and share your awesome solution. Really
You're
appreciate
welcome. It was my pleasure.
And thank you everyone who's attending for watching. Do come back next month. We'll be back with more amazing free SCOM community content. So thank you for watching, and thank you again, David. Until next time, thank you.